Algebra 1 Common Core Regents Review Quiz 2 Study Guide. So this is our second video in the Regents Review series. It's preparing my class for a quiz they're taking on these topics, but it's also just a great study guide for Regents Review. So operations with rational and irrational numbers. Which of the following sums is rational? This is one of the topics that was on the Regents Review 1, but I wanted to assess it again. And again, really, the keys to this is just remembering a couple of rules about operations with rational and irrational. And the first rule that should be remembered is that when it's a rational and a rational, the result is always rational. When it is an irrational and a rational, the result is always irrational. So if it's one of each, always irrational. Two rational, always rational. The issue is that when it's an irrational and an irrational, it could go either way. The answer is it depends. It's never always rational. It's not always irrational. It's sometimes rational and sometimes irrational. It depends on the numbers. And a lot of times in Algebra 1, we use square roots to represent rational and irrational numbers. And the key there is that if it's the square root of a square number, that is rational. So looking at these, like I see rad 4. 4 is a square number. That's rational. 7's not. It's irrational. 1 is rational. 9 is rational. 5 is not. 3 is not. And remember, when I'm talking about square numbers, I mean like 4 is considered a square because it comes from 2 times 2. 3 is a square because it comes from 3 times 3. 1 is a square because it comes from 1 times 1, right? That's 2 squared, 3 squared, 1 squared, right? But there's nothing times itself is 7. Nothing times itself is 3. Nothing times itself is 5. And so here is a case of one of each, so that result is going to be irrational. Here's 2 rationals, so it's going to be rational. Here's 2 irrationals. Now, that's a maybe, but in this case, it's irrational. And they want to know which of the following is rational. What's always going to be the double rational is always rational. So remember those rules, and it's really not too bad of a question then. Linear modeling. Now for these, we want to remember y equals mx plus b. And you want to remember that your slope, your m, is your rate of change, how the function is changing. Our b, the y-intercept, is our initial value, or where we start the function. So in a case of this, where they tell us that the cost for a school club to make t-shirts is C of S is 8S plus 15, and then they want to know what do the numbers 8 and 15 represent. Well, our slope here is 8, and 15 is our y-intercept. What this typically probably means is the m of 8, m equals 8, probably represents, if this is the cost to make the t-shirts, that's the cost to make each shirt. So like the more shirts you make, the more money it's going to cost you to make them. And so it's 8S is $8 per shirt. That's the rate, the slope. How is our model increasing? It's increasing by plus 8. So if I make one shirt, it's a certain value. Make another shirt plus 8, another shirt plus 8, another shirt plus 8. 5 shirts, I got to do 5 times 8. 6 shirts, 6 times 8. And then I got a plus 15 on the end, but it's always 8 times how many shirts I make. So they must cost $8 each to make. And then the 15, the y-intercept of 15, that's the startup cost. Maybe it costs $15 to open an account with the company that you're making it, or it costs $15 to design the shirt, and then it costs $8 to make them each, kind of thing. Maybe the artwork costs $15, and then it's $8 to produce them, but it's a startup cost. Another way of doing this is give you the context and write the equation. So if a student taking an algebra test out of 100 points loses 5 points for every wrong answer, write a function g of w to represent the grade a student receives relative to the number of questions they get wrong. So g of w, here I would say my slope here is going to be -5 because I'm losing 5 points every time. And our b, our initial value, is 100, right? You start off with 100. Sorry, those zeros are bad. You start off with 100 and then you lose 5 points each time. So you could think of this as 100 and then minus 5 per W. For every wrong question, it's minus 5. But if we want to put this in a normal standard form, G of W would be negative 5W would go first, and then plus 100 would go second. Our slope is negative 5. It's a negative because we're losing, we're decreasing value, right? I guess you could think of some tests as you start at 0 and then you plus 5 each time. I tend to think of it as you start at 100 and then it goes down for every wrong answer, but I guess you could go either way. But based on how they word this problem about losing 5 points, this is what they're looking for. Operations with polynomials, subtract this from that. Again, this is a repeat from the previous video, and it's something that comes up so common and it's so simple that you just have to remember that when you subtract from, that this goes first. So subtract, like if we're doing subtract A from B, you have to remember that's not B, that's not A minus B. Subtracting A means minus A. From B means B goes first. And so that's why this x plus 3 goes first. And we're subtracting 2x minus 1. So that's minus 2x minus 1. And don't forget to subtract it in parentheses. Always put these things in parentheses if they're not given to you in parentheses, because you're going to have to distribute that subtraction. And that's a common issue people forget about, is that distribution piece. And when I subtract a minus 2x, I like to write them underneath their like terms. And I'm going to minus a negative 1. And minus a negative 1 makes it a plus 1. And then I combine like terms. My final answer here will be negative x plus 4. Linear intercepts. Determine and state the x and y intercepts of the equation 2y minus x equals 10. Well, you have a couple options here. If you want to use your calculator, it's actually pretty easy, but you need it to be in y equals form. So first I'd have to add x to get 2y equals x plus 10. Remember, we want the x to be first for mx plus b. Then divide 2, divide 2, divide 2. That's going to end up with, here, I'll just do this, write this over here, y equals, now x over 2 is the same thing as 1x over 2, so that stays as a half x and plus 5. So here my slope is half, my b equals 5. That's your y-intercept right there. B equals 5. The x-intercept, well, if I'm using a calculator, I could just now type this into my calculator and look at my table or look at my graph and see, the x-intercept is when the y equals 0. But algebraically, if I want to find the x-intercept, what I could do is I could take my equation here and set y equal to 0. So let me just separate this. For the x-intercept, you set y equal to 0. And so we'll make that 0 equals half x plus 5. I can multiply everything by 2 here to get rid of my fraction. If I do that, times 2, times 2, times 2, that's going to be 0. All right, 2 times 0 is 0. 2 times a half is just 1x. 2 times 5 is that 10. And then I got a minus 10. Minus 10 equals x. And so that's my x-intercept. So my y-intercept is just the b, and that's, instead of making y 0, I make x 0. Half 0 is 5, so that's why it's just b equals 5. Now, you technically don't have to get this y equals mx plus b form to answer this question. For the x and y intercepts, I could just alternate plugging 0 in x and y. When I make y 0, I solve for the x-intercept. When I make x 0, I solve for y and get the y-intercept. So you could do it in this form here. I like to get it in standard form and then just see the y-intercept there and make the left side 0. But there's a couple of different ways to do it. And your calculator is very helpful, but you do need that standard form. Keep going here to solving inequalities. This is another repeat from the previous review video, but again, something that comes up a lot. The things that I think come up again and again and again are things that you're going to see me repeat a lot here. But it's also early in the year, so we've only covered about 5 chapters. Determine and state the largest integer in the solution for the inequality below. So I'm going to solve for x. First, I want to simplify same side like terms here. I got 6x, negative 4x. They're same side. So add 4 or anything like that. You only change signs when you want to move to the other side. But same side, just combine them as they are. Positive 6, negative 4, that's a positive 2x plus 3 is greater than 5x minus 6. Then I like x on the left, so I'm going to subtract 5x here, especially in inequalities. And 2x minus 5x, that's going to be negative 3x plus 3 is greater than negative 6. Next, I'll minus 3 to get the number on the right. So negative 3x is greater than negative 9. And then we divide. Negative 3, divide negative 3. Remember the golden rule here is if you divide by a negative, you have to flip the sign. Flip this inequality sign. So this is going to become x is no longer greater than, but less than. And a negative 9 divided by negative 3 is positive 3. So x is less than 3. The biggest mistake students make in inequalities is they do that and stop. A lot of times these questions want you to state something, not just solve the inequality, but state the largest integer in the solution. So of all the numbers where x is less than 3, the largest is 2. All the numbers less than 3, the largest is 2. That's really the answer here. This is just the work to get us there. Last topic here, domain and range. So given the function f of x equals x squared plus 2, if we have a domain of negative 2 to 1, what is the range? So remember that this f of x equals x squared plus 2 is just the same thing as y equals x squared plus 2. And the domain, these are my x values. So it's kind of like, all right, I have, negative 2, comma, what? Negative 1, comma, what? 0, comma, what? And 1, comma, what? Right? These are the x values, starting at negative 2, going to 1. And all the numbers between them. And these are less than or equal to, so I'm including these values, right? That could be thought of as a bracket, negative 2, 1, right? An interval notation. But I need to know the range. I need to know the y values that go with these. In my calculator, again, in my y equals, I could just type this in, look in the table, and pair up the numbers that go with them. Oops, sorry. Typed the keyboard by accident. But if I want to, algebraically figure this out, what we're doing, again, is these are the x values. I need to find the y's. So I just simply plug them in one at a time. So for x, so, that's what function notation is this is just the input. Plug something in there, square it, and add 2. Or I'm going to plug in negative 2. I'm going to square it, add 2. I'm going to plug in negative 1, square it, add 2. I'm going to plug in 0, square it, add 2. I'm going to plug in 1, square it, add 2. And what does this come out to be? Well, negative 2 squared, remember that would be a positive 4 plus 2 is 6. Right? Negative numbers, the negative 2 times negative 2 is positive 4. Don't think negative 2 squared is negative 4. Big mistake there. Negative 1 squared is positive 1 plus 2 is 3. 0 squared, of course, is 0 plus 2 is 2. 1 squared is 1 plus 2 is 3. Here, so our range is the values. If I want to do least to greatest, I'll do 2, 3, and 6. Right? And your domain here, which they gave us to start here, was negative 2, negative 1, 0, 1. And if you're ever given questions that give you the domain and range like this, your function, remember, could be any pairing of these numbers as long as your domain does not repeat. Range can repeat. I mean, we see that here. 3 is repeating. That's okay. This is a function. It passes the vertical line test if you look at this in your calculator. It's called a quadratic or a parabola. So the range can repeat, just the domain can. And we see that none of my x values are used more than once. That's why it is a function. All right, so that is it for Regents Review number 2. Good luck. See ya.